So last day we were discussing about projectile motion, and we have derived the expression for maximum height, horizontal range, and time of flight of the projectile. And today we have to continue that projectile motion, and we can show that there are two angles of projection for the same horizontal range. And for that we can see this derivation. When the object is projected with a velocity v0, initial velocity v0, and the angle of projection is theta, then horizontal range equal to v0 square sine 2 theta by g. That we have derived last class. When theta is the angle of projection, the horizontal range is equal to v0 square sine 2 theta by g, where v0 is the initial velocity of the body, theta is the angle of projection, and g is the acceleration due to gravity. When the object is projected with a velocity v0, making an angle 90 minus theta with the horizontal direction, then horizontal range will be v0 square sine 2 into 90 minus theta is v0 square sine 2 into 90, that is 180, minus 2 into theta 2 theta by g. So range equal to v0 square sine 2 theta by g. How you got this expression? Because sine 180 minus 2 theta and sine 2 theta are having the same value. 180 minus 2 theta is same as sine 2 theta. So we can write range. Now the range equation after equal to v0 square sine 2 theta by g. You see, for an angle of projection theta, the range is v0 square sine 2 theta by g. For an angle of projection 90 minus theta, also we got the same horizontal range. So what we can conclude from this, there are two angles of projection for the same horizontal range. Which are they? If one angle is theta, what is the other angle which gives the same horizontal range? 90 minus theta. For example, theta equal to 30. What is the other angle which can provide the same horizontal range? 90 minus 30. What is it? 60. So for an angle 30 and for an angle 60, both will give the same horizontal range. Another pair, can you tell? If one angle is 10 degree, angle of projection 10 degree, it gives a range. Which is the other angle which can give the same horizontal range? It will be 90 minus 10, that is 80 degree. So for but that pair 10 degree, 80 degree gives the same horizontal range. 30 degree, 60 degree. That is the pair which is giving the same horizontal range. Like that, you can find out the angles which give us the same horizontal range. And a graph is shown here showing this for an angle theta equal to 30 and for an angle theta equal to 60, the same horizontal distance is covered. That means from the origin to this point, for an angle 30 and 60 both cover the same horizontal distance along the x direction. But you know, the vertical distance in both is different. Here it is only this much vertical distance, but for an angle 60, vertical distance is more. Vertical distance covered will be more, maximum height covered will be more. But you know, compared to this angle 45 degree, we know the horizontal range will be maximum. So for any other angle, any pair of angle you can take, that will not cover more distance than this. That means for an angle of 45 degree. For an angle of projection 45 degree, that will be the maximum horizontal range. For all other angles, it will be less than that. Less than that. So next we have to study uniform circular motion. What is uniform circular motion? When a body moves in a circular path with uniform velocity. Uniform velocity means magnitude of velocity is same, but the direction of velocity is changing at every instant. For showing that, I will show a figure. The direction of velocity is changing all the time. You see this figure. See, when a body here, the body is moving along a circular path, and a arrow mark shows that it is moving in anti-clockwise direction. And when the body is at P, what is the direction of velocity, angular velocity? It is along the tangent. When the body is at Q, what is the direction of angular velocity? Along the tangent in the direction of motion of the body. That you have to tell, because body is moving in anti-clockwise direction. So you have to draw tangent in that direction. Tangents are possible in this in the direction of motion, this one. Opposite direction of motion, this one. Understand? So tangent, which tangent will give the direction of velocity? Tangent drawn in the direction of motion of the body. Okay, tangent drawn at that point in the direction of motion. Here it is in the direction of motion. Here in the direction of motion, tangent is drawn. So tangent drawn in the direction of motion at that point will give the direction of velocity. So well, direction of velocity is changing at every instant. So we can say it is an accelerated motion. Even though magnitude of velocity is same, magnitude of velocity is same. For example, body is moving with 5 meters per second. Magnitude of velocity is same, but every instant its direction of velocity is changing. So if magnitude of velocity changes or if direction of velocity changes, both are change in velocities. So change in velocity by time, that will give acceleration. So if either magnitude changes or the direction changes, both are the cases of accelerated motion, because change is there, change in velocity is there. It can be either in magnitude or in direction, both considered as an accelerated motion. Change in velocity by time, that is acceleration. So here circular motion is a accelerated motion. And other figure. Okay. Yeah, some terms connected with the circular motion we have to study. Terms. Time period. What is meant by time period? Time taken for one complete revolution. Time taken for one complete revolution. That is time period. This is one revolution. One body move from P and complete one circular path and again reaches to P. That is one revolution. And how much time the body takes to complete one revolution? That means start from P and move along the circular path in anti-clockwise direction and again reaches to P. That is that time taken for one revolution. That is known as time period. And what is frequency? That is number of revolutions in unit time. Number of revolutions in unit time. That is frequency. So what is the relation connecting them? Time period and frequency are inversely proportional. That equation is written here. Time period and frequency are inversely proportional. T equal to 1 by nu. If see the object completes new revolution in 1 second, and the object will complete one revolution in 1 by nu second. New revolutions in 1 second. So time for one revolution will be 1 by nu second. Therefore, time period T equal to 1 by nu. Nu equal to 1 by T. Nu into T is a constant. That is the relation. They are inversely proportional. Time period and frequency are inversely proportional. Time period T equal to 1 by nu. Then another equation for angular velocity. Angular velocity is angular displacement by time. Linear velocity is linear displacement by time. Angular velocity is angular displacement by time. Angular. Suppose when the body completes this figure. When body complete one revolution, that means start from P P and move along the circular path and returns to the point P. How much angle it traces this radius vector at the center? So this is the radius vector. This radius vector complete how much angle when it complete one revolution. Suppose this is initially it is 0, then 0, 90, then 180, then 270, then 360. So total angle it cover, the radius vector cover at the center of the circle. That is 360 degree. When we complete one revolution, the total angle subtended at the center of the circle by this radius vector, that is 360 degree. So angle equal to 360 and time taken for that is time period 2 pi by t. Angular velocity is angle by time. What is the time taken to one revolution? That is time period. What is the angle subtended at the center of the circle by the radius vector by that time? That is 360 degree or 2 pi radian. So angular velocity is 2 pi by t. Angular velocity is 2 pi by t. That is angular velocity is angle by time. Angle subtended when for one revolution 2 pi. Time taken for one revolution, that is time period for 2 pi by t. That is equal to 2 pi into nu. Because 1 by t is nu. 1 by t is nu. So you can write 2 pi into. Next, another term, angular displacement. That is angle subtended at the center of the circle by this radius vector. When body move from P to Q, what is the angle subtended? Body is moving in anti-clockwise direction. That's why arrow mark shown in this direction, anti-clockwise direction. So angle subtended at the center of the circle by this radius vector in a time, in a given time. That is when body moves from P to Q, what is the angle subtended? That angle is theta. With angular displacement theta. And angle how you find? Arc length by radius. Arc length. Join this P to Q with a straight line. That will give the arc length. Arc length by radius will give the angle. Angular displacement is a vector quantity. How will you find the direction of the angular displacement? For that you have to use right hand thumb rule. And I will show another figure. This figure is to know the direction of angular velocity. You can see a circle. Direction of motion of the body is anti-clockwise. So you have to take your right hand. Take your right hand and curl your finger. First you have to curl your finger perpendicular to thumb. Thumb and curl of the finger are mutually perpendicular. Then curl you have to show as shown in the arrow mark. Arrow mark direction you curl your fingers. Yes, you can see in that figure one arrow mark is first figure. Arrow mark is towards left, Like that you have to. So curl your fingers. 4 fingers you have to curl in the manner as we put the arrow mark in that figure. Like that you curl. Then thumb points in which direction? Upwards or downwards? Thumb is upwards. Okay. So direction of displacement gives. Thumb gives the direction of displacement. So what is the direction of displacement? It is perpendicular to the plane and upwards. Second figure you see. Curl your finger as shown by the arrow mark. Arrow mark you see. It is moved. Sense of rotation is clockwise. Curl your finger in that manner. Then thumb pointing in which direction? It is downward. Thumb is pointing in the downward direction. So the thumb direction will give the direction of angular displacement. And angular velocity is displacement, angular displacement by time. So angular velocity is direction, angular displacement direction, both are same. And how will you find it? Using right hand thumb rule. So curl of the finger represent sense of rotation. Thumb represent direction of angular displacement or angular velocity. Both have the same direction. So when it is anti-clockwise, thumb is upward. Angular displacement is upward direction. Angular velocity direction is upward, perpendicular to the plane and upward. When the sense of rotation is clockwise, angular velocity's direction is downward, perpendicular to the plane and downward. Then relation between linear velocity and angular velocity. For that, first you have to draw a figure. It's a very important derivation. Linear velocity is denoted with the letter V. Angular velocity is denoted with the letter omega. So first you have to draw a figure and explain. Here, suppose when the body is at P, the body is moving in uniform circular motion. And here this is the center of the circle and this is radius of the circle. And radius vector, when you see magnitude of the radius is same, but direction of radius at every point it is changing. When it is at P, this is the direction O P. When it is at Q, what is the direction of radius vector? Vector O Q. So direction of vector, position vector or radius vector is changing with time. And displacement vector, how will you find? Join with a straight line P to Q. When body moves from P to Q along the circular path, the straight line distance from P to Q that will give the angular linear displacement. Linear displacement. Okay, that is delta L. Suppose we can take that as delta L, linear displacement delta L. Then we know linear velocity is delta L by delta T. Therefore, delta L equal to V into delta T. And omega equal to angle by time. What is angle? Angle, this angle. How much time it takes to cover this angle? Suppose delta T is the time taken. Then delta theta by delta T, angle by time. What it gives? Angular velocity. Therefore, delta theta equal to omega into delta T. And we also know angle is arc length by radius. Delta theta angle equal to arc length delta L by radius r. Magnitude we are taking as magnitude. So we substitute above two equations in this expression. Angle equal to arc length by radius. Angle in the place of delta theta, what we substitute? Omega delta t. In the place of delta L, what we substitute? V delta t. So when we substitute delta t cancel and we get V equal to R omega. Cross multiply this. We keep it here and cross multiply these two terms. V is equal to R omega. So magnitude of velocity we got. This is the relation connecting linear velocity and angular velocity. What is V? Linear velocity V equal to R omega. And how will you find the direction of linear velocity at this point? Draw a tangent in the direction of motion. What's the direction of motion? This is the arrow mark. This is showing anti-clockwise direction, rotation. The body is along anti-clockwise direction. So here direction of velocity at this point. How will you get? By drawing a tangent at this point. Direction of velocity at this point. How will you get? Drawing a tangent in the direction of motion at that point. So magnitude of velocity is always say V equal to R omega, but direction of velocity is given by tangent drawn at that point in the direction of motion.